I will try to talk a bit about UVC. What is UVC and how does it work? UVC is light that we artificially get from bulbs like these. The sun also emits large amounts of UVC light, but fortunately it is blocked by the ozone layer, because UVC light has the ability to penetrate cells. When UVC light penetrates cells, it works by destroying the DNA and RNA. When you start working with it, you need to be aware that there's a big difference between viruses, bacteria, and fungi, and how much light is needed to kill them. When we work with UVC light, we talk a lot about dosage. And such a dose is always specified in joules per square meter. But when I have a lamp, it emits light as energy in the form of watts. You know this from having a lamp that's 60 watts or 100 watts. So you know that 100 watts gives significantly more light than 60 watts. The same applies to UVC. The big difference is just that when I have a 100-watt UVC lamp, I only get 40 watts of UVC light. The rest is wasted, and that's what you can see when the lamp is on. That bluish-white light. When I need to kill organisms, it's important that I know the organism I'm trying to kill. For example, if we're talking about E. coli, which most people have heard of, I know that I need to use about 30 joules per square meter to kill 90% of a given population of E. coli. That means if I have 100 E. coli in front of me and expose them to 30 joules of light, 90 of them will die. Salmonella is a bit harder to kill. For that, we need to go up to 40 joules. And that's how it is. There are many different values for the various bacteria. For a common cold virus, which we know from before, it only takes about 7 joules to kill 90%. For Corona SARS, we're looking at around 240 joules per square meter. So it takes many times more energy, and that's important to know when you're going to work with this. Are we talking about fungi? Those are some of the hardest to kill. The black mold you might know from the basement or the bathroom is called Aspergillus. For that, we're talking over 1200 joules to kill it. That means it's over 50 times more than what it takes to kill bacteria. This is important to know when working with UVC light. Another thing is, as you can hear, I always talk about killing 90%. I can also kill 99%. I can also kill 99.9%, but I can never kill 100%. Because this applies to all cleaning agents, cleaners, chlorine, alcohol, everything. We always talk about being able to kill a certain portion. You can't achieve 100%. It's not possible, because there will always be a bacterium, a fungus, a virus that survives. And that's why we always talk about killing 90 or 99 or 99.9%. In principle, if I kill 90% with 30 joules, then I need 60 joules to kill 99%. And I need 120 joules to kill 99.9%. So it's also very much about energy, about finding the right level. But that's how UVC works. It penetrates the DNA, RNA, and destroys it. And if you know the differences between the various organisms, you can also calculate how much light is needed to kill them.